Let's make a garden pot that can tell you when the plant needs to be watered. This is a fairly easy project that almost anyone can do. Let's begin the build process. Alright, so first let's place the Arduino Nano onto the breadboard, and we'll connect the ground to the ground line. Next, we're going to hook up the series of LEDs. First, we need to hook up the first resistor for the first LED. There's a link in the description to one of our videos that tells you how to calculate which resistor to use with the LEDs for your Arduino project. We're connecting the LEDs from digital input 2 all the way to digital input 6. Now let's add the sensor that will detect the amount of moisture in the soil. We'll be measuring just general capacitance, so we're going to connect the ground from the Arduino to the analog input 7 of the Arduino. Then we connect the sensor to the pins/wires we just added, and we turn the Arduino on. Then you put the sensor in the soil. We only put the sensor about halfway in the soil. It seemed to get a better reading that way because we're not using any kind of amplification circuit. You can basically control how long it takes to get down to red by how deep you put it into the soil. Let's take a look at the code. Up at the top we have our variable declarations. These are all the things we're going to be working with, like the sensor level, all the averaging stuff to average the sensor level to a smoother reading. And then we have the LED states. 0 means off. If the LED is on, it will be 1. Alright, so next we have the setup section. We're going to begin the serial communication, and that'll let us see the sensor readings through USB. And then we're going to create the array for the averaging. After that, we're going to turn on the red LED. Now let's move on to the main loop. We're going to do an analog read on analog input 7, and that'll become the sensor level variable. We're going to take that sensor level, send it through all this averaging code, and that'll give us our average over the last 50 readings. It reads super quick, so every 50 readings is way less than a second even. So once we get the average, we're going to go through these if-else statements. The first one turns on the orange LED. Since we have the sensor hooked up from ground to the analog input, that means when there is water, it should theoretically go down to 0 on the sensor reading. So that means the lower the sensor reading, the damper the soil is. So what we're going to do on this first one, if the sensor reading is below 200 and the orange LED is currently off, then we're going to turn it on with this digital write command, and we're going to set the state to 1 to let it know that it is currently on. Then we have the else statement right here. If the sensor level is above 200 and the LED is currently on, then turn it off because there's not enough water present to justify having that LED on. We also changed the LED state to 0 to signify that it is currently off in the system. After that, we do these other if-else statements. They are just at slightly lower numbers for the sensor level, and they control the rest of the LEDs. LED 2 is the yellow LED, LED 3 is the green LED, and LED 4 is the blue LED. The red LED gets turned on in the setup section. That's kind of like your power light in a way. The rest of them are turned on down in this section down here, depending on the sensor level. This is an easy project that almost anyone can do. The knowledge is readily available and the possibilities are endless. What are you gonna make?